26. Okay. That's not 26. So the big thing about 26 is kind of having to draw a circle. So 26 started off with just this square drawing, and these little beautiful petal-looking things. And I said the radius of the square is 2 centimeters, which means the center to any corner is 2 centimeters. So what I did is I basically said, I'm going to find this, because this looks like stuff we've been doing. Right there. Let me color that in. This is what I'm looking for, because in these problems, this is exactly what I'm looking for. I'm either looking for a sector I can find, or I'm going to find this little segment that I've colored in like here. I'm looking for what are all these segments. Now, if I find this, I just have to multiply it by 1, 2, 3, 4, 5, 6, 7, 8, because I have 8 of them, and I have my answer. So I just need to find this little sliver, this little red sliver, and multiply it by 8. Well, to find that sliver, I first need to figure out the measure of that angle, which is 90, right? We're dealing with a square, so that has to be 90. So I have at some point I have to use 90 divided by 360, right? That's the whole point of coming up with that. So I have my 90 divided by 360 times pi r squared, but I need to figure out what my radius is first. I need to figure out what my radius is. So what I did is I pulled out this triangle. You see this triangle I pulled out here? And I knew this was 2, and I knew both of these lengths had to be the same. So it's just 2 sides are all the same. So that gives me the opportunity to find that. Right? X squared plus x squared equals 2 squared. I got down to my radius is square root of 2. And really, once I have the triangle and this angle, I have everything I need. Because now I know my radius of my circle is square root of 2. Plug that in. Minus my area of my rectangle, or my triangle, which is half my base times my height. My base and height are both square root of 2. Plug that in and multiply it by 8. All right, I think that's a trick to almost all of these, is to figure out this little segment. That's what I'm looking for. I'm looking for this little segment. Yeah?
So to figure out the half of no matter what is given, even if it's already almost looks like half.
Yes, is probably a good assumption. Now, it's not going to work 100% of the time, but in these problems, it pretty much worked. Even if it's half of it, you're still doing half of half. Kind of. So really, I think that was a trick to almost all of them, is drawing a circle and find that little segment is your starting off point pretty much. But is that good? Yeah, Amber.
28.
28? All right, 28, we have 3 circles with radii 6 are tangent to each other. So this one, once again, is one of those kind of just drawing the picture right. And once again, this would be one on the test I'd already have drawn for you. Because if you draw them wrong, because I know some people put them like this. Some people had them like this. They had to be like this. All right? And since each of the radii is 6, since they're tangent, this is 6, well, this is also 6. So that makes this side 12. This side 12, that side 12, which means it's an equilateral triangle. So all those central angles are 60 degrees. Well, guess what? If I find this big triangle, this 12 by 12 by 12 triangle, if I find that entire area, and then I subtract out all these little sectors. So let me count. I want to subtract out this sector, and this sector. So if I find the area of this big triangle, subtract out that red area, I'm just left with that black area, right? So big triangle minus those sectors. So we just need to find the area of the big triangle. And then what's the area of our 3 sectors? Well, each of those sectors is the same size, right? They're all radius 6. So all I'm going to do is, well, my triangle is half my base times my height. Well, my base is 12. Using the fact that we have a 30-60 triangle, you can easily find the height, right? Which is down here if you didn't. And we subtract away our 3 sectors. That's why I have 3 times. Well, this central angle is 60 with a radius of 6. So that area is going to be 60 divided by 360 times pi 6 squared. You can almost see that squared. I should have. You can all see
Yep,
that squared,
got it.
right?
Yep.
Yep. All right. So that's the area of my triangle minus the 3 sectors gives me that little shaded region in there.
Okay.
Other questions? That's it. Mr. Reiner show up yesterday? Okay. Did he help you out? Yeah. He knows this stuff pretty well. We're good otherwise? All right. Then let's just roll right into today's lesson. I'm surprised no one had questions on 29. I guess 29, once you kind of see the drawing, it makes sense. It's getting to that drawing that makes it really hard to figure out what you're looking for. So I don't think any one of these questions is like ridiculously hard, like it's pages of work. I think the big part is, what am I looking for? What sectors am I looking for? What triangles am I looking for to subtract from it? I think those are the hard parts. So my advice on the test, if you get one that you're just not sure how to answer, start finding sectors, start finding triangles. And at least you get points for that, right? You're like, I know the sectors involved, Mr. Pagan. I can find this area. I don't know what to do with it, but I know I need it because it's right there. All right. Okay, then let's go into today's notes. Today's notes is getting into ratios of areas. Let's go all the way back to that first thing. So let's build this up. So our whole goal is if I have two similar objects, and I know something about both those objects, I want to be able to compare their lengths, I want to compare their areas, and to a lesser extent, volumes. Volumes is actually going to be our next section, so that's 12, but this is kind of segue into it. So we're not going to really have volume on the test, so focus more on the area and the length size. All right, so we're doing ratios of areas and lengths and volumes, slightly attached. So it says right here, I want to find the ratio of length triangle ABC to length triangle XYZ. And we're saying that these two triangles are congruent to each other. So we can really compare any lengths we want to as long as they're those similar lengths, right? I don't want to compare this base to this height. That wouldn't make sense because that's not the ratios. Remember when we worked with ratios? If I'm looking at the base of one triangle, I need to compare it to the base of the other triangle. So let's go ahead and use the bases of the triangles to come up with our ratio. So let's do the base of ABC. That is 20. So the length of ABC, our base, is 20. And we're going to divide that by the base of XYZ. The base of XYZ is 14, correct? Is that right? 16. Is it 16? Okay. It's really blurry up here. It is really blurry up there. Thanks for all the anger. All right, but obviously we're going to reduce that, right? What does that reduce to? 20 over 16. Amber? 5 over 4. And just if you don't believe me, if I would have did the heights, I would have did 15 over, I hope that's 12. Which would also have been 5 over 4. So it doesn't matter which height you would have picked, the height or the base, or any one of these, they'd all have that ratio of 5 over 4. All right, now let's find the area of triangle ABC. Well, the area of triangle ABC is 1/2 our base, which is 20, times our height, and maybe I'll just use multiplication instead of those. Times 20 times our height, which is 15. The area of triangle XYZ is going to be 1/2. Our base of that one is 16 times the height, which is going to be 12. Can somebody tell me what that comes out to? Stephen, yeah. 150 over 96. That's what I got to.
Wouldn't we just finding that one? The face of it?
Yeah, we're just finding the face of it. Yep.
Oh, why is it 3D then?
It will be 3 because we're looking for volume. In a second, we'll be looking at volume. All right, 150 divided by 96. Can someone simplify that for me? Yeah.
Oh, it would
the simplify by 4.
Okay, and what does that come out to? You were 100% right on that. I'll give you a second.
37. Wait. 37.5.
Ooh.
Wait.
It'd be 150 divided by 4. No, not 4. I'm sorry.
2. 150 divided by 2.
Try by 2.
75 over 48.
I think we go a little further.
75 over 48, and then 3 by 3. 75 divided by 3. 25
Yep.
over 25 over 16.
16, which I want to reduce a little bit further. Not reduce, but change how it looks. 25 and 16, those are perfect squares, right? So I can rewrite 25 as 5 squared. I'm kind of running out of room. Over 4 squared. Well, that's odd. We had 5 and 4 over here. Now I just square it, and I get my area ratio. So if I find my length area, and I square it, I get my area ratio. What do you think we're going to do to get our volume ratio? Following that pattern, yeah? Cubit. All right, so for volume, we have to add depth into it. So to add depth into it, we're going to take our area, which is 150, and multiply it by 10, the depth of the object. Because that's what gives us our 3-dimension. I take the face, and we push it back 10 units. All right, and then I'm going to do the same thing for the bottom one. That one also gets pushed back. That's my blurry. I have it 8 units. So we're going to have 96 times 8. So we have area times the depth. Which is going to equal 1,500 over 760. Which, just to help us out, is going to end up equaling 5 cubed over 4 cubed. Did I have the wrong number somewhere?
Yeah. 68.
Oh, it is 68. You are 100% correct. My beautiful smudged writing isn't always as clear as I'd like it to be. Yes?
Did you ever do the length times the width times the height?
We did. Wait, say that again?
The length times the width times the height with volume?
That's the volume of a square or a rectangle. It is always area times the depth of the object. Because I'm taking this face times that face plus that face plus that face until I get all the way over here. That's what volume is. It's area times the depth in which it's working on. So you're looking at a rectangle, so you do the face, length times width times depth. We should go there, but we're talking about a triangle. All right, so let's put this in general. If my length ratio is A over B, then the area ratio is going to be A squared over B squared. Then my volume ratio is going to be A cubed over B cubed. Remember, we're not going to talk much about volume at all. We're more or less just prepping ourselves for our next section. We're more worried about the area and that length one. All right? So if you're a little confused on the volume one, that's okay. We're not in that section. All right. I'm going to rewrite that right here. No, I'm not. But just in case you missed it, so it's A over B. Area is A squared over B squared. Volume is A cubed over B cubed. All right, that first problem says that we have a triangle ham and rib, sounds delicious, with AM equaling 16 centimeters. It also says the area of ham is 96 centimeters squared, and the area of rib is 54 centimeters squared. So what they gave us is a side. They gave us the side. How much room did I leave us for this one? Oh, I did. I gave us enough. So they gave us a side, and they gave us the area. So it says the area of ham equals 96 centimeters squared. And rib is 54 squared. Can someone simplify that for me? I was like, just, especially when there's twos that I could take out of there. Akshay? 16 over 9.
4 squared over 3 squared.
It is going to be. So remember our area ratio is a squared over b squared. So this would be 4 squared over 3 squared. Yeah.
Will it always be perfect?
It won't always be perfect. Sometimes you have to take the square root of both of them. You might have like the square root of 7 over the square root of 5 or something. Just recognize to get from area back to length, you do take the square root of both sides. So length is just a over b, which is going to be 4 over 3. In other words, once we know the area, take the square root of both of them. So maybe I'll mark that down too. This is the square root of 16. This is the square root of 9. Because as Evan pointed out, sometimes they won't be perfect. Sometimes you'll actually have to just take the square root, have square root of 5 over square root of 2. Something that's not nice and even like that. But happy-go-lucky, everything works out in the notes. Because why give you the hard stuff in the notes? All right, it says the area of ham equals, so it says that ham is similar to rib. So let's go ahead and draw those for our next one. So let's draw a triangle ham and a triangle rib. Let's just draw our triangles, try to draw something that looks semi-similar. Let's do that. Let's do that. And now, remember, order matters in how I write this. If I write H-A-M, I have to then write R-I-B. Similar, so that means H matches up with R, A matches up with I, M matches up with B. Make sure you write these correctly. So if I'm doing ham like this, that means I need to start with rib down here, R, I, B. And knowing that angle H is the same as angle R, angle A is the same as I, and B is the same as M. All right, they gave me one little bit of fact. They gave me that AM equals 16. So AM equals 16, and they're looking for IB. Let's go ahead and call it X. So we're looking for IB. What am I going to do to get IB? I don't even know what to do. Yeah.
So you do 4, 4 over 3
Okay, let's try it. 4 over 3.
equals 16 over x.
Okay. Does it matter what order I do this in? Could I do X over 16 and it'll still come out with the right answer?
It matters.
How do we know what matters? How do I know which order to do it in?
Because you would be saying that the x is AM.
AM is the other way around, and 16 is IB.
Okay.
So, and you just cross multiply now.
Yeah, now we just cross multiply. So it matters if I pick 4 over 3, which goes in the next one, right?
Yeah.
All right, so now we just cross multiply. We just cross multiply. We would get 4x equals 3 times 16. So we are going to have 4x equals 48. So we're going to have x equals 12. Did I do all that right? Are we okay with it equaling 12?
No.
No? Oh, I don't know. Are we okay? No one is?
Yes.
Yes? Okay. So that means IB equals 12. I need at least one person saying it's right. Otherwise I feel self-conscious. All right, so we have IB equals 12. We use that. Now, my hint on this whole section, make sure you know what you're talking about. And what I mean by that is don't all of a sudden use the area ratio to compare lengths. Don't use lengths to compare area. I always think area is the squared. Your length is the square root of the area or your A and B. It can get kind of confusing because you're going to have lots of ratios floating around in your head. Just ask yourself what you're looking for. Area is the squared. Length is the ones that aren't squared. All right. Let's do another example. So this one says cat is similar to MSE with ME equaling 6, CT equaling 12. If the area of cat is 72 centimeters squared, what is the area of MSE? So this one we got a little bit more room. So let's go ahead and draw these pictures. So let's draw cat. Let's draw cat. And we're going to draw MSE. And make sure order is correct. CAT, so I have to have M, S is on top, E is on the bottom right. Yeah, Evan.
Can we just start from the beginning and go like 6/12, and that equals.
Yeah, we could. I just want to do it with drawing because it's our notes. It's our notes. I want you to be able to look back at that and know what you did in a month. All right, so we have ME equaling 6. We have CT equaling 12. And I also, inside of one of these, we have the area of CAT equals 72. So I'm going to put that in there. And we end up looking for this area. So 72, the thing we're missing is X. So let's compare our lengths. Our length ratio would be 12 over 6. I'm just going to use 12 over 6, which is going to be 2 over 1. I'm going to leave it as 2 over 1. I'm not going to make it 2 because it starts getting confusing if you lose your fractions. Yes?
You use 12 over 6, but would it matter if we did 6 over 12?
Nope.
It wouldn't change.
It's only going to change the order of the next thing, right? Because when I'm looking at the areas, I'm going to have 72 over X. You're just going to have X over 72 instead. We'll come up with the same answer. Yes, it does not matter if you did 6 over 12 or 12 over 6. All right, so our ratio of lengths is 2 over 1. So let's get our ratio of areas. Well, that means we're just going to do 2 over 1 squared, right? So we have 2 over 1 squared, which is going to be 4 over 1. That is now my ratio of areas. Now we can go ahead and find our stuff. Yeah?
Y squared. Where do you have
If our length ratio is A over B, our area is A squared over B squared.
Okay.
That's what I was saying. You got to be really careful about what you're dealing with. So I don't want to just find the ratio of lengths and compare it to areas. I need to square it to get my ratio of areas. All right, so now we have our ratio of areas, so now we can go ahead and find this. So if we do 72 over X, that's going to equal our ratio of areas, which is 4 over 1. Robin, yours is going to be X over 72 and 1 over 4, right? Now we're going to cross multiply. So we're going to have 4 times X equaling 72. What does my X equal? Evan. 18. And I'm going to have 18, and I'm going to put a little thing on there, centimeters squared, because it did say, we start out with centimeters squared. Once again, warning, warning, warning. Make sure you recognize whether you're dealing with length ratios or area ratios. All right. So we have, I guess, a four-sided figure called rect and angle. If the ratio of their areas is 9 over 6, what is the scale factor? So our scale factor is just the lengths. Our scale factor is our lengths, comparing lengths. So if our ratio of areas is 9 over 16, who can give me what that length ratio is going to be? Akshay. It's going to be 3 over 4. In other words, we have square root of 9, square root of 16. What would the ratio of their perimeters be then? Anyone want to take a guess at that? Yes, Rena.
Would it be 3 over 4 plus 3 over 4 plus 3 over 4 plus 3 over 4?
Not quite. It'd be kind of similar. Actually, what do you think?
It's 3/4.
It's still 3/4. It is still 3/4. Because when we dealt with scale factors, if we said the difference between one length to the other is 3 over 4, adding all those lengths together, dividing by all the other lengths would still be 3 over 4. So that ratio is still preserved. So perimeter and lengths have the same ratio. The only difference comes in when we go to area. All right, now it says, now if LA equals 24 centimeters, then what is the length of TR? So let's go ahead and draw these shapes. Now I'm just going to draw them as rectangles because we're not 100% sure, but rectangles are usually the easiest to draw if I don't know what's happening.
I'm guessing it's a rectangle.
Could be. We have rect and angle. I don't know if that stands for rectangle, but who knows. All right, so I'm going to set this one up as T. Where did I start? Let's start our top left. So I made it rect, which means my A needs to be up in the top left, and I need to follow that angle like that. All right, we said LA equals 24. That means we must be looking for TR, which is our X there. Well, our length and perimeter ratio is 3 over 4. The 3 and the 4. 3 and the 4. So we said the ratio of their areas is 9 to 6. That means the 9 went with rect. 16 went with the angle. So 3 goes with the rect. 4 goes with the angle. So that means this is my top. This is my bottom of my fractions, right? All right, so we're going to have X over 24 is going to equal that 3 over 4. Which is then going to give me 4X is going to equal 72. So X is going to equal 72. In other words, our TR. Oh, I'm sorry. I didn't actually do the division. 18. That means our TR is going to equal 18. Did we have centimeters or anything? Yes, we did. So we should say 18 centimeters. Yeah, Sabrina.
Wouldn't it be 18 over 24?
It would not be 18 over. Where'd you get the 24 from, I guess?
24 is on the bottom, so like the, what you call it?
So we did cross multiply. So I do 4 times X and 3 times 24, right? So I cross multiplied. So I went 4 times X and then 3 times 24, and 3 times 24 is 72.
But the problem is like, wouldn't it be like that 18 is always over like the other number, like the lengths are always like that?
Nope.
Oh, so you just
We just get the ratio and solve for X.
So it depends on what the problem is, like if it's
I'm not sure what problem had the 24 on the bottom.
like the
Which
number 3 where it was like
number 3?
yeah, or it's like kind of like 3 over 4.
This one?
Yeah.
This is what is our ratio.
Oh.
This is what is our ratio. This is use your ratio to find a size.
Oh, okay.
Okay? So it is just going to be 18 centimeters. It won't be over 24. Because this is, we're just using the ratio. This is finding our ratio. All right, I think we just have one more. We have area of Zoid equals 16. Area of trap is going to... Careful, it's a trap. All right. So what I'm thinking about with A and B is I'm thinking about, well, 16 is actually 4 squared. And 25 is 5 squared. So I'm talking about A being 4 and B being 5. So that means our length ratio is just going to be 4 over 5. Where Zoid is on top, trap is on bottom. And just because it's kind of out of order, I am going to label it as top and bottom so I don't forget. It's not so bad when we go left to right, but sometimes when we go the opposite direction, we get messed up. All right, we are supposed to find... oh, hang on. That's not what I wanted. Those are actually the A's and B's.
But if you want to be done then.
Oh, we were almost done. It was actually 5 and 10. Because A is going to be 5 and B is going to be 10. All right, yeah, we would have been done, right? So our length ratio is 4 over 5. So we just have to use that length ratio to get our A and our B, with this being top and this being bottom. So the first one we're going to have is 4. I should use different variables. 4 over A is going to equal 4 over 5. You do not need to cross multiply this. If this is 4 over 5, what's the only thing A can be to make these two things equal to each other? You mouthed it. 5. It needs to be 5. So you can jump straight to the fact that A equals 5. I'm just going to circle it there. I don't like it being here because it's right next to here. So in fact, I'm going to scribble this out. I'm going to change that in the notes after. I don't like that it's right next to it. So we have A equals 5. Let's go ahead and do B. Well, B is going to be 8 over B. Still equals 4 over 5. Once again, if you didn't want to, you didn't have to do super math, because I need to multiply 4 by 2 to get 8, which means I multiply 5 by 10 to get B. That's kind of a shortcut on these. I am going to cross multiply, though. So we're going to have 4B is going to equal 8 times 5, which is 40. So B is going to equal 10. So the point of this one is just basically objects can be split twisted. All right, don't just assume what's on the bottom. DZ does not match up to TR. Make sure you do similar shapes, have similar sides. Make sure you pick which ones are the similar sides. All right, questions on that? Questions going once? Twice? All right, let's go ahead and get started on the homework. While you are working on it, I'm going to come around and I'm going to check your 11.6 B and C.